summation of a finite geometric series of all four of the formulas or the types of problems, I would say this is probably the easiest of them all. Now, I will tell you though, you will have some of your largest numbers with these problems. Okay? Don't try to do everything at once. But for the most part, it's really not, you're going to be given a lot of the information just because there's really no other way to do it. There is one type where you're going to be given the sum that you're going to have to kind of go back through and use a little bit of your logarithm knowledge. But other than that, it's really pretty straightforward and pretty simple. So whenever we use the sum of a finite series or a geometric series, here's your formula. You really only need, again, three things, just like yesterday. You need the first term, you need to know what the common ratio is, and you need to know how many terms that you have. Okay, so they're either going to, and for the most part, we're going to have to give you the first term just about every single time. If you're going to have to find anything, you're going to have to find how many terms you have in your series. Okay, so first term, common ratio, and the number of terms. So if we find the sum, if it's a summation from the first 10 terms, your rule is 4 times 3 to the I minus 1 power. Again, your rule, S sub n, equals the first term times 1 minus r to the n power over 1 minus r. Now, whenever we do this, it's really pretty simple as far as where everything is. The only term that you're going to actually have to plug in here is for the first term. And for the most part, your first term, depending on your rule, a large portion of the time, it's going to be whatever that number is. Okay? Especially if you have like I or n or x minus 1 as your power. So all we're going to do is just plug in and go 4 times 3 to the 1 minus 1 power. Well, what's 1 minus 1? 0. So I have 4 times 3 to the 0 power. What's anything to the 0 power? 1. So it's really just 4 times 1, or my first term is 4. Now, with my rule, I need to find the first term. I need to know what is r. What number is going to get multiplied all the time? The 3. Okay? It's the number that's the base. Okay? The base of your exponent, that is your r. So the base is 3. And then the last part, how many terms are we going to add up? 10. So now we go to our formula. If we're going to find the sum of the first 10 terms, we're going to take 4 times 1 minus 3 to the 10th power over 1 minus 3. Now, before you do anything, okay, here is the order in which you want to solve everything. Okay, the first thing I want to do is the top right here. Okay, the top of my parenthesis is the first thing. Do this first. So if I go 1 minus 3 to the 10th power, I get negative 59,048. Second thing I want to do is going to be the bottom side of my fraction. So what's 1 minus 3? Negative 2. Just because you get a negative up in the numerator, don't flip out, because for the most part you're probably going to get a negative on the bottom side, or if it's positive, for the most part you're probably going to get a positive on the bottom side. Okay? A majority of the time you will have values that will cancel out, and like if the top's negative, the bottom will be negative. That's not always the case, but it will happen a lot. Now from here, it's completely up to you as far as what you want to do. If you want to stick with what's in the parenthesis and go negative 59,048 divided by negative 2 and get 29,524, that's fine, and then multiply by 4. If you want to do all of this together, I have no issue in that. Okay, so my answer is just 118,096. So now, second example. Again, I need to know the first term, I need to know what the ratio is, and I need to know how many terms. What are the easiest two parts? Ratio is probably the easiest part, right? Which is 5. What's the second easiest part? Probably n, which is 6. The hardest part is probably, if anything, and it's really not that it's that difficult, is going to be to find the rule when your I is 1. So when 1/2 times 5 to the first power, what's 5 times 1/2? Just 5 over 2, or if you want to call it 2.5, that works too. I would probably stay away from the decimal, but it's really okay. If you want to put it as 2.5, that's okay. So now we just plug everything in. So first term, 5 over 2, or 2.5, however you want to do it. 1 minus 5 to the 6th power, all over 1 minus 5. Now, one thing that usually, do not try to cancel the 1 and then the 5 and the 6 and all that. What are we going to do first? Do the top. So I'm going here first. So 1 minus 5 to the 6th power. And I'm going to get negative 15,624. And I'm going to divide by negative 4. Whenever I do, I have 5 over 2, or 2.5, whatever you want to use, and 3,906. Multiply that by 2.5, or 5 over 2, 9,765. And even when you have the list makes it easier. Because from now, we're going to have, do we know what our first term is? Yeah, negative 12. Can we figure out what our ratio is? What are we doing to get to the next term? Multiplying by 4. How many terms do we need to find? 8. It tells us everything that we need to know here. Okay, so if you have the list, having the summation notation and having the rule probably is more difficult than if you have the list. Because if it tells you, hey, we need 8 terms, here's your first term. You can figure out that we're multiplying by 4, and if you aren't sure how to do that, all we have to do is just take one of these two numbers, take the first one, all we did was to go negative 48 divided by negative 12, and that's how we got the positive 4. Then it just becomes plugging it into our formula of S sub n equals a sub 1, 1 minus r to the n over 1 minus r. So the sum of the first 8 terms here is going to be negative 12 times 1 minus 4 to the 8th power over 1 minus 4. Again, top first. Always do that part first, and then everything else will fall in line. So 1 minus 4 to the 8th is negative 65,535. All over negative 3. And we're going to multiply by negative 12. Now, if you don't want to divide that number by 3, or negative 3, that's fine. You can cancel this out and turn that into a positive 4 and just multiply it there. Does that make sense? Hey, if you want to cancel things, that's completely okay. I have no issue in you doing that. So we're still going to get the same answer of negative 262,140. If you want to divide this part by negative 3 and then multiply by negative 12, that's fine. All we did was just cancel the negative 12 and the negative 3 and turn it into 4 over 1. So, on this last one, it says the sum of the first n terms of a geometric series is negative 819. Find the number of terms. So, this one is going to be, of any of the ones that you do, these are going to be the longest ones, just like they have been all chapter. As far as if you have the sum or you know what everything is. Do we know what the first term is? First term is 1. Do we know what the ratio is? Negative 4. Okay. Do we know how many terms we have? No, that's what we're trying to figure out, right? What do we know, though? We know that the sum is negative 819, right? So we're going to use that formula that we have of S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So just get in where it fits in. So negative 819 equals 1 is my first term. 1 minus negative 4 to the n power all over 1 minus negative 4. Now, a little housekeeping. What can we do to the denominator spot? Make it 5, or change that here. So we have a little house cleaning. Do we need to worry about the 1 anymore? No. Okay, so I have negative 819 equals 1 minus negative 4 to the n power. The one thing, all over 5. The one thing I cannot do, okay, that is a common mistake, and don't let this happen, is do not change that to a positive where it's highlighted. Okay, do not change it because it has the n power to it. We can't change it to a positive because that completely changes our answer. So now it just becomes solving. We want to get the exponent here, or the power, by itself. So what do we need to get rid of first? What do you want to get rid of first? Okay, so if we get rid of the 5, what do we need to do to both sides? Multiply both sides by 5. So whenever we do that, we get negative 4,095 equals 1 minus negative 4 to the n power. Now what? Now what do we need to get rid of? The 1. So subtract 1. So we have negative 4,096 equals negative of a negative 4 to the n power. Now what? What can we get rid of? Get rid of the negative. Just divide by a negative 1. So we have 4,096 equals negative 4 to the n power. Now, with that, what do you know? What kind of number is n going to be? To make even, because this has to be positive, right? Now, here is, and I'm going to go up here to the top so I have a little bit more room. Okay, so if I have 4,096 equals negative 4 to the n power. What I'm going to have to do with any of these problems is I'm going to have to change it into a logarithm. Now, the one thing that cannot happen, okay, I have to know my power rules and have to know that this has to be even. Okay, because if it has to be even, isn't this right here just the same as 4,096 equals 4 to the nth power? Since it has to be even, isn't it going to work to be the same thing? Yeah. Okay, so you have to know your power rules, because if I take a log of a negative, I can't take a log of a with a negative base. All I'm going to do is change a base, or rewrite it as a log rather. So if I go log base 4 of 4,096 equals n, do you remember what change of base was? Log of 4,096 divided by log of 4. So log of 4,096 divided by log of 4 is just 6.